In this video, we are going to discuss about the adsorption process used for the dehydration of natural gas. So, adsorption is basically the solid desiccant process. So, what are the advantages for the solid desiccant process over the liquid desiccant, that is the absorption process? The first one, we can go for the dew point as low as minus 150 degree Fahrenheit, and normally it is not achievable in the liquid desiccant process. They are the less affected by the small change in the gas pressure, temperature, the flow rate. This is one of the advantage of the solid desiccant. They are less susceptible to corrosion or foaming because of the solid material, and that's why they are very much less affected by all these parameters. The disadvantage of the solid desiccant over the liquid desiccant, that is the absorption process. So the first one is the higher capital cost and higher pressure drop. The second one is the desiccant poisoning by the heavy hydrocarbons H2S and CO2. So that is a problem of the poisoning, means inactive. It will be inactive when there are heavy hydrocarbons or the acid gases. So there are mechanical breaking of the desiccant particle is possible because it is a solid. So mechanical breaking because of the high pressure and continuous process, continuous flow. These are the chances. Fourth one is the high space and weight requirement for the solid desiccant. Obviously, it is much heavier as compared to the liquid desiccant. High regeneration heat requirement and the high utility cost. So for the regeneration, we need a very huge amount of the heat, and the utility is also required. So this is all about the advantages and solid disadvantage of the solid desiccant. Then, if we define the adsorption process or the solid desiccant process, it is a dehydration process, whereas solid desiccant is used for the removal of the water vapor from the natural gas. So that is a simple definition. The solid desiccant commonly used for the gas dehydration are those that can be regenerated. So it is a regenerative process and consequently used over several adsorption-desorption cycles. So although there are a few solid desiccants that cannot be regenerated, but now in the commercially we have to use the solid desiccant that is regenerative in the nature. So the mechanism of, if you go for the mechanism of the adsorption, how these things are happening, so we can divide the mechanism in two processes. One is physical and the second is the chemical adsorption. So in the chemical absorption, the process is named as the chemisorption. So in the chemical adsorption, very fine and limited applications in the gas processing. Normally the physical absorption is going on. Main one is the physical absorption. So the solid material, that is the adsorbents that allow the physical absorption, hold the adsorbate on the surface by the surface process. So in the physical, basically in the physical absorption process, the main forces behind the physical absorption is the physical process, surface forces you can say. So, and then the regeneration is very easy if the things are adsorbed by the physical absorption mechanism. So there are different types of the adsorbents, that is solid desiccant for the physical adsorption. So what should be the desirable property required for the physical absorptions? So these are the few properties. For example, number one is the large surface area for the high capacity. Commercial adsorption have the surface area between 500 to 800 meters square per gram. So that is the first requirement. Obviously, the large surface area is always desirable for, because the things are going on the surface basis. So more surface area per unit mass means more adsorption and the more water removal is possible. And second is the good activity for the components to be removed. So, and good activity retention with time or with use. Commercial adsorbent can remove the particles, all the water from natural gas to volume as low as 1 ppm. So if you look here, the very low concentration of the water will be left out in the natural gas. The third advantage is the high mass transfer rate in the physical absorption process. So if there are high mass transfer rate, then high rate of removal is possible. And the next is the easy economic regeneration is possible. A small resistance to gas flow, so that the pressure drop to the dehydration process is very small, because very less resistance for the gas flow is there. High mechanical resistance to resist the crushing and dust formation. And cheap, non-corrosive, non-toxic, chemical inert, high bulk density, high volume change upon absorption and desorption of water. So these are the few properties that are required for any material that can be used as a physical adsorption in the physical adsorption process. So this is all about the desirable properties and the basic information regarding the adsorption process. Thank you.